Defining nuclear fusion. Nuclear fusion is the process in which two light atomic nuclei combine to form a heavier nucleus, releasing vast amounts of energy. This process powers stars, including our Sun, and has the potential to provide a clean and virtually limitless source of energy if harnessed on Earth. Defining nuclear fission. Nuclear fission occurs when a heavy atomic nucleus, such as uranium or plutonium, splits into two smaller nuclei, releasing energy in the form of heat and radiation. This reaction is the principle behind nuclear reactors and atomic bombs, producing energy by breaking down heavy atoms. Energy production mechanisms. In nuclear fusion, energy is released by the joining of nuclei, which requires extremely high temperatures and pressures to overcome repulsive forces between atoms. In nuclear fission, energy is released through the splitting of nuclei, which can be achieved at much lower temperatures compared to fusion. Fuel sources. Fusion typically uses isotopes of hydrogen, like deuterium and tritium, which are abundant in nature and relatively safe. Fission uses uranium-235 or plutonium-239, which are rarer, require enrichment, and come with radioactive waste concerns. Byproducts of each process. Fusion produces minimal waste, with the main byproduct being harmless elements like helium. In contrast, fission creates radioactive waste, which can remain hazardous for thousands of years, presenting significant challenges for waste management and storage. Safety considerations. Fusion is generally considered safer than fission because it does not produce long-lived radioactive waste, and there is no risk of a catastrophic meltdown. Fission, however, carries risks of nuclear accidents, as seen in events like the Chernobyl and Fukushima disasters, and involves the handling of radioactive materials. Energy efficiency. Fusion has the potential to be more energy efficient than fission. The energy released in fusion is far greater relative to the amount of fuel used, while fission is already quite efficient but produces more waste and requires more resources for fuel extraction and processing. Current applications and challenges. Nuclear fission is widely used today for generating electricity in nuclear power plants. Fusion, while promising, is still in experimental stages due to the extreme conditions needed to sustain the process. Achieving controlled fusion on Earth remains a significant scientific and engineering challenge. Environmental impact. Fusion is seen as a cleaner energy source, with no greenhouse gas emissions during the reaction. Fission, although low in carbon emissions, produces radioactive waste and requires the mining and processing of uranium, which can have environmental impacts. Conclusion. Choosing between fusion and fission. In conclusion, nuclear fusion and fission are both powerful energy-producing processes, but fusion offers cleaner, safer, and more sustainable energy with fewer environmental impacts. However, fission remains the primary method for nuclear power generation today, while fusion research continues to hold the promise of revolutionizing energy production in the future.